Welcome. You are viewing one of 10 modules developed through a project funded by Geoscience BC focused on direct-use geothermal resources in British Columbia. This follow-up project was carried out between August and December 2016. The project was executed by Tuyaterra Geocorp. These modules were developed from the Direct-Use Geothermal Resources Roadmap published by Geoscience BC in June 2016. They incorporate additional educational material that were developed as part of the current FollowUp Project. The voices you will hear narrating the module are myself, Catherine Hickson, and my colleague,
Juliana Proenza.
Juliana, why don't you explain what we're going to do?
So this series of modules are separated into 10 different sections. We are currently on Module 1, and this webinar index will be available to you at the start of every module, so you can orient yourself within the steps that we'll be taking you through. There are going to be a series of topics that we're going to cover that were explained through the initial project, and at the end, after all modules are completed, there will be a summary of the follow-up project that we completed at the end of 2016.
So this one is really just to give you that orientation. We're going to introduce what was done and then give you a project overview. So the project was essentially part of the work that Geoscience BC has been doing in order to try to increase the awareness of British Columbians of geothermal energy in the province. What we did was take an earlier project, which was focused on electrical generation, and look at how that geothermal resource might be utilized for direct use geothermal. We have 3 phases to what we did. First one, data gathering, then we had community engagement, and then our final was completing a report, and that this decision matrix we will talk about in a few minutes. But the second part was creating a roadmap, and that roadmap was intended to help communities understand the resource and how to develop it. So the roadmap is a guide, step by step, how to develop the resource. But what we encountered in the project is that there's not that many people with enough technical background to really take on a geothermal project in their community. So that's partly why these modules were created, to help explain what was in the roadmap in a simpler manner, and also just to help you work through the modules. So this is the part of the follow-on project. So the 2 documents were created, and now we have been working with communities and with individuals such as yourself or groups to help them understand what in fact was created. Juliana, do you have anything else to add?
Yes, so during this follow-up project, we tried to build upon the community engagement and capacity building that took place during the initial part of the project. The initial project took place between September of 2015 and March 2016, and then there was a couple of months leadway to summarize and publish the report, and then we picked up again in August and continued on with this community engagement. Part of the follow-up project was to present the results at various forums. Initially, we wanted to present the information in a series of regional workshops, but due to several factors, what ended up happening was that we presented at kind of separate forums where it wasn't a workshop format, but it still was able to access a series of communities in different regions of BC where they could be presented the information and follow up as they wished with our assistance. We also touched upon trying to contact different educational institutes to see if they would be interested in incorporating some of our learning material into their programs. And 3 examples of these institutes are BCIT, here in the Lower Mainland, Thompson Rivers University in Kamloops, and Northern Lights College, which has several campuses in Northeast BC.
So let's talk about what geothermal is all about and how you go about developing it. So there's a number of steps in the process. You need to identify the resource, you then need to explore for it, you need to drill, then you need to decide how to build, and then you need to develop it. So let's walk through those steps one by one. So for the next few slides, we're going to focus on electrical generation geothermal resources. And electrical generation requires higher temperature than direct use. So you can think about direct use as the use of hot water to, say, heat your home or heat a greenhouse, where electrical generation needs much higher temperatures because what we're trying to do is run a turbine to create power. So for electrical generation, we need a lot more information than what you might need for shallower either geo-exchange or lower temperature direct use. And those three categories of information are geological data, geochemical, and geophysical data. And what this is doing is telling you, these three parameters are telling you something about what is below the surface. How hot is it? How deep is it? We put those groups of information together in a conceptual model, and that conceptual model tells us something about what the resource is going to be like in terms of its temperature and its volume, and then we do exploration drilling. So as we move downward on this diagram, the time that is spent is increased significantly, as well as the costs. Do you add anything, Ilana?
So we've also included here the resource estimation aspect, which is something that's much more relevant for electrical generation and resource development with respect to power production. And although there is some work that is required in order to evaluate the resource for direct use applications, the information needed may not be as rigorous as required for power production.
And I think that is really shown here. Now this slide has a lot of detail in it, but that detail is all the different kinds of information that are required if you're doing geothermal exploration specifically for deep exploration and particularly for high temperature, or at least medium to high temperature. And that's because it's a very expensive undertaking that you have to do. And that expensive undertaking is because you're drilling large diameter wells at great depth. So in this diagram, the upper part actually we can look at the diagram in two different ways. One is vertically and the other is horizontally. So if we look at the vertical axis first, you see target identification, prospect evaluation, and then project appraisal. So what we're doing in target identification is we're seeing, is there a viable potential geothermal resource out there that we might be able to tap? Once we've made that identification, and we do that by using the geophysical information, geochemical information, as well as geological information, we then need to decide, well, if we have this resource, is it worthwhile doing further exploration? And then finally, once we decide that there is in fact a resource down there that has potential, then we go into the project appraisal. We need to find out more about it. And how we find out more about it is by drilling. So let's move to the next slide. Because as we're moving across this diagram, diagonally, we have the most expensive part of the process in the lower right-hand side and the least expensive in the upper left-hand side. So as you're moving across this diagram, you have to remember that both time and complexity and costs are increasing. Now, what we're doing is we're taking all that information and we're now trying to put it into a development matrix. Now that is what you see here, and you see it in terms of years. So what is important is to appreciate that geothermal projects, high temperature, particularly power production processes, take time. They take time and they take money. So you can't produce power in a year. It's going to take you several years. And typically, a 5-year time frame is not an unreasonable time frame. Now what you see here on this diagram is the types of things. So we were talking earlier in the last slide about project definition. So we're going to be doing our geology, our geochemistry. Then we're going to identify drill targets. We're now going to start drilling those, and that's what that black diamond is the decision to go ahead, because now we're into a much more expensive part. And if you look at the lower part of the diagram, you see equity financing and debt financing. What equity financing is in the case of a private sector company, they have to come up with money to do all of the initial work until you get to the red line. After the red line, you can do debt financing. Essentially, you can go to a bank and you can get financing for your project. So to the left of the red line, you have to come up with shareholder money. To the right of the line is debt financing. Now, in order to give you an idea of what that looks like, we have to look at the fact that typically it's about $3 million per megawatt to develop a geothermal resource. So if we're talking about 100 megawatt, we're talking about needing to come up with a total of $300 million. And of that, about half, maybe less than half, something like 100 million or 70 million, will need to have as equity financing. And the reason for that is that banks typically require 70% steam behind pipe. So that means that a company has to come up with significant funding that they get through shareholders or some kind of equity financing before they can go to the bank and get debt financing. This is one of the largest hurdles that geothermal companies have in producing power projects, is getting over that red line. And that red line is very significant, and it's reflected in this diagram. So this is the time that has elapsed between the first discovery well. So that discovery well has usually taken several years in order to gather the geological and geophysical information. And now we've got the money together, our equity financing, and we're drilling our first well. And that discovery well was successful, but even though it might have been successful, it's still taking a number of years before you can develop the field. And this is just a range of projects around the world that show you what that time gap is. If it's an expansion to an existing project, like the Salak that you see at the very bottom, that only took 3 years. But there are a number of projects such as El Tatio in Chile or Oaxaca in New Zealand that have taken many, many decades to come to fruition. So what our objective was, because of these large hurdles for electrical generation, and those hurdles are important for British Columbia, a second hurdle is not just the equity, the difference between equity and debt financing, but it is also things like transmission. In British Columbia, many of the geothermal resources are not close to transmission, and transmission is a very expensive part of the process. So what Geoscience BC decided to do was to fund a project which is looking more at the direct use. So this is the lower temperature resource. Temperature that can be used for greenhouses, it can be used for drying. There's many different aspects that direct use heat can be applied for. It's cheaper in order to explore for it. It's cheaper to develop and is an important part of what we think is the resource for British Columbia. So, take to add something there, Juliana?
So, just to go through some of the details that we went through when we worked on the project was, one of the objectives was the potential to reduce greenhouse gas emissions for communities and drive economic development, and just really raise awareness about the different possibilities of applications that can be used with direct use geothermal resources in BC. And this information was really focused on the 11 sites that were deemed favorable for electrical generation in the report that we've mentioned previously, and that report was published in 2015. And there was an additional 7 sites that were deemed unfavorable that we also included as part of our summary in order to evaluate how these sites could be potential resource areas for the communities nearby. So a total of 63 communities were contacted, and through this process we provided this information to these communities. And although we have touched upon some GeoExchange information, and we will be touching upon some GeoExchange development resource information, this study in particular did not focus on heat pumps, which is another word for GeoExchange, because this resource can really be developed across the province. It doesn't require anomalous geothermal flow. So even though it was not included in the study, we did recognize that the deployment of heat pump geothermal technology is really a crucial and important aspect of direct use resource development, particularly for raising awareness of these types of applications.
So as Juliana has said, the work that we're doing now is based on the earlier work that was done by Kerwood Lydell and Geothermics. And in that they focused on the 11 favorable sites. What we did, because direct use, we don't need the high temperatures that you need for electrical generation, we could expand that. And we expanded it to include essentially all the communities that were within areas that had evidence for a higher temperature waters than just basic groundwaters. And those are all shown here on the map.
So you can see that the green stars are the 18 different sites that were covered by both projects, electrical generation and direct use. And then we've got the hot springs in BC. Obviously, the most important ones will be the red and the most visible ones in the areas. And then we've got the communities that were contacted in yellow, and the communities that responded in purple. And there was only a few communities that really were engaged during the process of that project, which is why we've been extended to work on this follow-up project.
But there is significant resource in British Columbia, not just those specific sites. And this map, in the colors that you see, shows you some of the extent of where there could be warm waters or warm rock. So the pinks and reds are areas that have what we call anomalously high gradients. And this means that, for example, if you drilled down 1 kilometer in the pink areas, you would have higher temperatures than if you drilled 1 kilometer in the areas that are blues and greens. So what this map shows you is that the area of pinks and reds is more expansive than specific communities. And this means that there is potential for geothermal, particularly direct use geothermal, which requires lower temperatures, in areas beyond specific communities. So what we did is taking that map that you've just seen, as well as all the communities and the prior work that has been done, and we started to engage the communities, and we did that through sending them a questionnaire. Then we evaluated each of these areas using what we call the Geothermal Development Decision Matrix, and that was to help us rank so that we could decide where to focus our efforts. Now, in that first phase, so we were gathering the information about where the resource was and where the community was, but our next phase was how do we engage that community and how do we build their capacity? Juliana, do you want to talk about this in more detail?
Yes, so we contacted the communities, as Kathy mentioned, and provided a survey questionnaire that we would have liked to have had more response to. But within that process, what we really realized was the necessity for the roadmap, which is something that was carried out during phase 3. And the steps involved during this engagement process consisted of things like reviewing the community's official plan or an energy plan if available, and any other information that the community had that was relevant for resource development in general, any technical information that was gathered for the favorable geothermal sites, and disseminating this information in a format for the communities to access. And then once we provided this information, we followed up several times to see if they needed help completing the survey and fielding any particular questions that the community may have had.
So this next slide is really just about the details of that work. The communities were contacted up to 5 times, but we had 4 communities that were particularly engaged in geothermal. Those are Valemount, Nasco, the Tahltan area, and the Nukshuk First Nations. So these groups already were aware of geothermal resources in their territory or in their region, and we were able to gain a significant amount of information from them. But what we did find, as Juliana has already mentioned, that there is a knowledge gap, and that's why we developed the roadmap. And that roadmap is to help communities move through the development process, move through the process of deciding whether or not they have a resource, and then how to use that resource.
And one of the big things that we wanted to push forward was that although this project was available and the resources from the project were available in order to assist communities in development decisions, this type of resource really does require a community project champion in order to further the steps of development, get the information out to the public at the community level, and really just engage successful community capacity building at the organization, individual, and municipal level.
So in order to help decision makers focus resources, we went through the Geothermal Development Decision Matrix. And what we did is all the information that we had gathered from the various communities we put together in a large matrix, and we gave a weighting. But what is important about that weighting is we weighted the resource as equally to the community. And as Juliana has just mentioned, what we found is important in communities that want to move forward on development. There needs to be a champion. And that's why a community that is open and interested in moving forward is so important, as important as the resource itself. Now, each of those categories is broken down into smaller levels. For example, the resource has it been evaluated? What's the resource risk? What do we know about it? What maps are available? On the community side, we have things like the water rights, engineering. Is there an infrastructure that can be used? And that's because access and constructability are so important. It's not just the community, but can you get to the resource? So we put all of this together in order to help us rank communities. So here's our ranking that we came up with. And I think that what is important about this ranking is it's not, it really isn't sort of good or bad. It is, here's the communities that we looked at, here's what we think about what their potential is to develop geothermal resource. Now, be very clear that, or we want to be very clear that this is about a medium to higher temperature resource. This does not include geoexchange. And as we'll talk about geoexchange later, geoexchange is really can be used anywhere in the province, but using warm groundwaters has specific regions, and those regions are in areas, or best known in areas where we already have hot springs available. So what you'll see here in terms of the communities is the ones that came out top were the ones that already have an identified resource in the form of hot springs and have a community that is already aware of and interested in development of their hot springs. But all of the other communities have some potential at some level. And I think that's a very important thing to emphasize. This was really a process that we went through to find out what information is available and what additional information would be needed. So some of the communities that got a lower score on here were really, it was about the lack of information as opposed to negative information. I think that's important.
One thing I would like to add that I think is really exciting is that the 4 communities that are circled here, that's Vail Mount, the region near Clark Lake, which is Fort Nelson area, Lake Ellis Lake, which is near Terrace and Kitsellis, and Slowcat Creek, which is within the Zaza Douglas First Nation territory. These are actually all areas that have 3 of the 4 of the areas have projects that are currently being developed. 2 of these are Vail Mount and Lake Ellis being developed by Borealis, and Slowcat Creek is being looked at by the Zaza Douglas First Nation Band to evaluate a tourism, recreational activity area. And Clark Lake, although there isn't project going forward, there is a project that is being funded by Geoscience BC that will start in January of 2017, looking at the pre-commercialization value of that area, and all of the communities in that area are very much aware of this resource and have shown quite a bit of interest in furthering the resource potential from a community level.
Okay, now let's talk about the roadmap. So we've got communities that have resources. How do we help them move forward? How do we help you understand what your geothermal resource is and what you can do with it? In order to do this, we created the roadmap, and that really is a way of showing you how to do the various aspects of geothermal development. You need to understand how you do exploration. How do you acquire the land? What kind of permits do you need? What's the cost of drilling? How do you test those wells? And then, once you have a resource identified, how are you going to design and construct those plant facilities? You need to take into use things like cost of transportation of direct use process. If you're talking about using the warm water to heat a greenhouse, well, where are you going to sell your product to? So all of those things are covered in the roadmap. And that roadmap is, it's written as a book, and it's written as a way that will guide you. So taking the roadmap and looking at that, you can look back through the original report, and our geothermal development matrix will give you some idea about what is available information for your particular community. You can take that, you can then read through the roadmap, and decide what it is that your community might be able to do. And in conclusion, though, these modules are meant to make that even more accessible, to help you understand what's in those various modules, listen to the information, and then make some decisions for your community.